Hello dear students, I would like to proceed with our lectures on the topic of usage of Laplace transformation for determination of the transient processes in linear circuits. And now I would like to depict you how to use this approach for obtaining solutions. I would like to remind you about our previous lectures. It was that we can use Laplace transformation for writing first Kirchhoff's current law, for writing second Kirchhoff's law, and therefore we can use all methods for determination of currents, voltages, with the help of Laplace transformated parameters. And here are replacement of real schematic by the so-called operational schematics. It was depicted earlier, and in such a way we can transform a real schematic in their operational form in such a way. And when we get Laplace image of some parameters, for instance of current, here it's Laplace image, to transact from Laplace image to a function of time to the so-called original of this Laplace image, we should use a different approach. We can use just inverse transformation, Laplace transformation, but it may be rather difficult. It may be used also formulas, known formulas, to transact from Laplace transformation of the known of some set of functions, and I have depicted how it may be done for our example for such a schematic. And at last, the most spread method is usage of the so-called decomposition theorem. And in previous lecture I have shown you how what this theorem looks like, and I have shown you this decomposition formula of decomposition theorem, which permits us to transact from Laplace image of some function to its original to function of time. And such decomposition theorems tells us that if we present thought parameter written in the form of Laplace image, like ratio of some numerator and denominator to a denominator, and if these functions can be presented as a rational regular fraction where m the highest degree of polynomial function of the numerator is less than higher degree of the polynomial function of denominator, m less than m less than n. And we present such function in such a way where phi1 from P is numerator and phi2 from P is denominator. We just present thought function in such a way, and you see it is in our example we just have presented thought function, it is I from P, as a ratio between polynomial function in numerator and polynomial function in denominator. So it is phi1 from P and it is phi2 from P. And now I will show you how to use this decomposition theorem to get a function of time to obtain real solution, or from knowing this operational image, Laplace image of here of current I of the considered schematic. So we've got in operational form this I from P function, and we write down that it is expression in numerator we equate it to phi1 from P, and expression denominator we equate it to phi2 from P. So phi2 from P here it is this expression in denominator, and phi1 from p its expression in phi1 from p its expression in numerator. To get to transact from function of Laplace to function of time, at first we should determine roots of denominator. You see, we have here denominator, and these p1, p2, and so on, pn are roots of denominator. So we should equate denominator to 0 and determine roots of this expression. As it may be seen that first root is p equal to 0. Second root may be got when we equate this expression in brackets to 0. So from here, p second root equal to minus 2r over 3l. Okay. Then we should determine phi1 from pk. Phi1 from p1 from the first root can be got by substitution this root in expression for p1. When p equal to 0, we will get this summand will be equal to 0, so we will have e multiplied by 4r. Okay, it's phi1 from p1. Let's determine phi1 from p2. Substitute this root to this expression. It will be e multiplied by 3r multiplied by 2 minus 2r over 3r. 3r and 3r will be cancelled, and we will have here minus 2r, that will be this item, and plus 4r without r. So it will be e multiplied by 2r when we substitute this root in this numerator, phi1 from p. Then we should determine derivative from denominator by p. It's phi2 derivative from phi2 by p. This sign means. So let's do it. You see, first summand here will be 6rl multiplied by p power 2. Its derivative will be equal to 12rl, that's all. You see, 12rl, multiplied by p, because it was p power 2, its derivative will be 2 multiplied by p. It's for the first item, and for the second item it will be 4rp. Its derivative will be equal to 4r, 4r power 2 p. Derivative will be 4r power 2, that's all. Okay, so we've got expression for derivative by p of denominator. It is here. Then we should substitute each root in this expression, for derivative by p of denominator. First root p1 equal to 0. When we substitute it here, it will be this summand will disappear at p equal to 0, so it will be just 4 multiplied by r power 2. It is here. Then when we substitute second root equal to minus 2r over 3l here, it will be with minus 2r over 3l multiplied by 12rl. It will be, you see, it is here, plus 4r power 2. You see here, 3r and r are cancelled, and we have here 24 over 3, it will be 4, no, 24 over 3, it will be 8 r power 2 with minus, yes, minus 8 r power 2 minus 4 r power 2, it will be minus 4 r power 2. So its expression for phi2, derivative from phi2 substitution root p equals p2. Okay, then we have all necessary calculations have made it. So we should substitute got expression to this formula. You see, it will be phi1 from p1 over phi2 prime over p1 multiplied by in the degree p1 t. How now it is here, then plus phi1 from p2 over phi2 prime from p2 multiplied by e in the degree p2 t. It is just writing down this expression. It is for k from 1 to n, where n equal to 2. So we have here only two summands from this sum, and they are written in this way for when we substitute first root and then we substitute second root. And let's write it phi1 from p1 equal to e multiplied by 2r. So it will be e multiplied by phi1 from p1 is e multiplied by 4r. So it is e multiplied by 4r over phi2 prime from p1. It is phi2 prime from p1. It is 4r power 2. 4r power 2. You see, it is here multiplied by in the degree p1 equal to 0. So it will be in the degree 0 multiplied by t. It's for the first item when we substitute got levels, and then for second, phi1 from p2 equal to e multiplied by 2r, e multiplied by 2r in numerator. In denominator it should be p2 prime from p2. It will be minus 4r power 2. It is here, yes, and multiplied by e in the degree minus in the degree p2 t. p2 equal to minus 2r over 3l multiplied by t. Then we rearrange it, and we will have here e in 0 degree, it's 1. Here we have r and r power 2 are cancelled.
Вот что об этом говорится в источнике.
It will be e over, it will be e, you see here we have 4 and 4 are cancelled, r and r power 2 cancelled. In denominator will be only r, so it will be e over r for the first item, and for the second item it will be, here we have r and r power 2 cancelled, only r in denominator, 2 and 4, 2 in denominator, this minus before this fraction, and we have e over 2r multiplied by e in the degree minus 2r over 3l multiplied by t. So we've got the same expression which we got when we use, you see, the same. Sorry, 1 minute. It is here the same expression as we got with the help of usage of known transaction from function from Laplace images to function of time. Just the same expression we've got by another approach. And we may see that it is more common approach, and it will be used for any functions not dependent of whether functions may be transacted using known formulas for transaction from Laplace image to function of time or no. And in the next lecture I will explain you more items, more information about usage of Laplace equation of Laplace transformation. Bye for now.